Now I want to look at four properties of integrals. So before we go talking about how to calculate these integrals, we'll look at these four properties which will become useful. Now let's just recap that if we've got a function, so here's my f of x, and I want to calculate the area underneath between those two values, a and b, so this is x, and here's my y is a function of x. I want to calculate the area between the function and the x-axis. So if I want to calculate that area, we can say that this area here is equal to the integral. It's a long elongated s, so that's the integral sign between these lower bound and the upper bound, a and b, of f of x dx. So that will give me the area. So let's look at the properties. First property says that if we've got two functions added together, when you find the area underneath those combined functions, you can actually just find the area under each of the individual functions and then add the two together. So that may be useful. Must be between the same bounds, a and b. The second property is that if you've got a constant, so here c is constant, so it's not a function of x, can't have any x's in it, so it might be just 3.5 times this. You can take the constant out the front of the integral sign and then just do the integral of the function itself and then multiply by the constant at the end. The third one is that if you want to integrate between a and c of this function, f of x with respect to x, and you know that in between a and c you've got an x value of b, then you can integrate between a and b and then add the integral from b to c of the same function. Now, probably best to try and do some sort of graph here. So here's my f of x, and here's my a, and here is my c. So I want to find, this is saying go find the area between a and c, between the function and the x-axis. So I want to actually calculate that area. And what this property is saying is that if b lies between a and c, so let's just put b anywhere, say there. If I find the area between a and b, so that'll be that one there. So where it's cross-hatched, that'll be the area between a and b of f of x dx. And then if I just add from b to c, so I add this one here, I'll get the total area. Common sense. Okay, number 4 is that the integral between a and b of f of x dx. So when you're integrating from a and b, it's conventional to go left to right. So a is always on the left of b, but if you did it in reverse order from b to a, it would just be the negative result. Okay, so those four properties may come in handy for you.